hope to return to face-to-face events as soon as the circumstances allow us to do so. I'd also like to take the opportunity to thank our sponsors, Freshwater Group. So Freshwater Group are a specialist recruitment firm working in the energy sector, and their ongoing support helps us to continue to run events like this. So we thank them tonight. So for tonight's presentation, we have two fantastic speakers to delve into the topic of renewable gas for us. So our first speaker is Jordan Mccollum. Jordan is the National Policy Manager at the Australian Pipelines and Gas Association. So Jordan is a career gas industry professional, experienced in the commercial, operational, and innovation management of technically complex energy value chains. In his current role, he seeks to utilise this experience to drive policy change which enables the Australian transition towards a renewable gas future. And our second speaker for tonight is Chrissy Robin. She is Head of Strategy and Innovation at the Australian Gas Infrastructure Group. So in this role at AGIG, she is a key part of her work is focused on implementing the long-term vision for the decarbonisation of AGIG's infrastructure through renewable gases such as hydrogen and biomethane. Chrissy's played a key role in the development and delivery of several renewable gas projects, such as Hydrogen Park South Australia, Hydrogen Park Gladstone, and Hydrogen Park Murray Valley, which we will no doubt be hearing more about later on tonight. So just some housekeeping before we start. We'll have a Q&A session after the presentations. So I encourage you to post any questions that come up throughout the presentations into the Q&A function through Zoom, and then we'll address these questions at the end. We do ask you if you have a question that's specific to one of the presenters, just to make it clear in your question who the question is directed to. Also, one final thing, just a reminder that tonight's session will be recorded, and we'll make the recording available to our members on our website after the event. Okay, so that's all from me. I will now hand over to Jordan to kick us off.
Thank you very much. I'll just take a second to share my screen. Alrighty, I believe I'm on.
Yes, we've got you now, Jordan. Thanks.
Thank you very much, Lucy. I really appreciate that. G'day, everyone. My name's Jordan Mccollum. I am the National Policy Manager for the Australian Pipelines and Gas Association. We're the peak energy body representing the gas pipeline industry in Australia, as well as everyone in all shapes and forms involved in the industry, alongside our main owner members as well. AGIG is one of our great members, so very glad to have Chrissy speaking tonight as well, and very much looking forward to seeing some interesting insights from the projects they've been running. So I guess just before I step into my my presentation, anyone who's come across me before knows that I'm pretty passionate about this renewable gas stuff. And that comes from a bit of history where I spent a good part of my first decade in the industry working on a mixture of operational engineering and commercial aspects in the industry, and through that kind of two realizations dawned on me at around about the same time. One of them being that, this gas infrastructure stuff, it's just got so much potential. It can move such large volumes of energy, such long distances, store energy in the same assets, and do it all at a relatively low cost. But at the same time, it was really dawning on me that we're going to have to decarbonize. There's no two ways about it. We've got to end up in a net zero energy system. So that was very conflicting until I came across the concept of renewable gases. The ability to still utilize all the versatility of gaseous energy, but without the carbon footprint, that's really, really exciting from an energy nerd perspective. And I'm definitely an energy nerd. So we'll kick off a couple relatively simple questions today about renewable gas. What are they, and why are renewable gases important? And the easiest way to really start the conversation about what are renewable gases is to relate them back to natural gas. So as many of you will likely already know, natural gas is a variable mixture of a range of light hydrocarbons, predominantly methane, with various different mixtures of ethane, propane, etc., and a couple other non-combustible gases, and it's essentially used as a gaseous fuel. Now, the big problem being that these natural gas comes from under the ground. It is a fossil fuel. As much as it is the lowest emission fossil fuel, it's still an emissions intensive fossil fuel. And that's a problem. Yeah, we need to decarbonise. So in considering a renewable gas, there are really two pathways or two predominant pathways in which we can go to arrive at a renewable gas. The first pathway is to find another combustible gas that doesn't emit any CO2 at all. That's where we have the renewable hydrogen pathway. Hydrogen, as I'm sure many people know as well, when combusted, only produces water. In producing hydrogen, you end up with sometimes a few extra little bits and pieces in there, maybe a little bit of oxygen, a little bit of carbon dioxide, depending on the process. And it's predominantly produced from either an electrolysis process using renewable electricity, or through some other thermochemical process. The other approach to creating a renewable gas is to create a hydrocarbon where the source of the carbon in the hydrocarbon has come from the atmosphere rather than from underneath the ground. And that's where that's where we have our renewable methane pathways, be they biomethane, where the plants draw biological resources draw carbon from the atmosphere and then get processed into methane, or through a synthetic process where CO2 is absorbed from the atmosphere combined with hydrogen to create methane. Either way, we're keeping the CO2 in the short carbon cycle, hence it's considered carbon neutral from a Scope 1's emissions perspective. Interestingly, you can actually create each of these from the other. Through reforming renewable methane, you can create renewable hydrogen, and through combining renewable hydrogen with renewably sourced CO2, you can create renewable methane, which is really handy. So there's a whole bunch of different ways to do this, and I'm not going to go through them all. Here's a really messy slide of a bunch of the ways that people are currently talking about doing this. On the left-hand side, a few different pathways to creating hydrogen, and I do say on this slide renewable and decarbonised hydrogen. And on the right-hand side of the slide, we have some pathways to creating renewable methane. And as you can see on the hydrogen side, we've got our renewable electricity to electrolyzer pathway. We've also got the old coal gasification pathway with CCS. You've got your biomass gasification, which actually can be carbon negative. And all of these flow into hydrogen transport and utilisation. Whereas on the right-hand side, we have our various biological processes feeding into forms of processing that wind up in a form of methane, or our synthetic process of creating hydrogen, combining it with CO2 captured from the atmosphere, methanation, and we have hydrogen. Now, I'm not going to dwell on these slides, and I'm hoping that the slide pack will make it to everyone so you can have a bit of a look at your own leisure. But ultimately, what we get at the end of the day is two flammable, combustible gases that we can use as a fuel that don't have carbon emissions. And that's really, really useful. The more interesting question, though, is why are renewable gases important? And this is what gets me really passionate. So I'm going to start this conversation with a really monumental feat that we've been able to achieve in Australia. And that's in that in 2020, we were able to achieve 24% renewable electricity generation as a percentage of total generation in Australia. And that's a really, really monumental feat. Australians should be really proud about being able to achieve that 24% level. And it's a testament to the effort that's been put in over the last decade or two to really drive the development of the renewable electricity industry. But importantly, electricity isn't the only piece of the puzzle. This is data from the Australian Energy Statistics demonstrating the various different forms of energy that are used or consumed by Australians. Now, this is just domestic consumption. If we were to add exports to this, we'd add another 15,000 odd petajoules on top. But just looking at domestic energy consumption, only 19% of energy in Australia is used as electricity. 22% of energy in Australia is used as gaseous energy. 52% liquid fuels, 3% direct use of coal, funnily enough. And there is a 4% direct use of renewables, which are actually predominantly biological in nature. But the important thing to recognize here is just how big this stack is to solve, and the fact that this 24% that we've been able to achieve is only 24% of this. Now, to me, that's a little bit scary, because that means that we need to essentially do what we've done over the last couple of decades 20 odd more times to solve the entire problem of decarbonising all energy use in Australia. Now, sure, that's based on the current energy demand, and with transitioning to electrical appliances, we're going to have electricity efficiencies involved. But even if those efficiencies halve the amount of energy, that's 10 times more what we've already achieved, just being solved by the renewable electricity sector. The question that leads me to ask, though, is what if renewable electricity didn't have to solve the entire problem alone? What if other forms of renewable energy, be they solid, liquid, or gaseous, could also help solve this problem? Now, of course, I'm the gas guy, so I'm going to talk about renewable gases, not the renewable solids or renewable liquids. But renewable gases give us an opportunity to have another way of solving this problem. But thinking about how we solve this problem with renewable gases, we need to stop thinking about gas as just a fuel and think about it as an energy medium, molecules as an energy medium. And to do that, I'll take you through a relatively simple description of the basic energy medium model for solid, liquid, gaseous, and electrical energy. Because no matter what the medium, all four of these types of energy have essentially the same structure. They are produced, there is wholesale transmission, there is distribution to customers, there is storage occasionally, most of the time somewhere in the middle, and there's utilization at the end. This is relatively familiar for the electrical energy value chain, where we have electricity generation, transmission power lines, distribution power lines to homes and businesses, battery storage, pumped hydro storage, and other electrical storage in the middle, and thermal, digital, or impulse use at the end. This is also relatively familiar for liquid fuels, with oil production and refining, transmission pipelines and shipping of fuels, fuel bunkering, mostly around ports. In some countries, distribution pipelines. In Australia, distribution trucking, and thermal and internal combustion use at the end of the day. Solid fuels get a little bit more abstract, with coal mining and drying feeding predominantly rail transport networks, with a little bit of conveyor distribution and trucking at the other end, coal stockpiling representing energy storage, and thermal use occurring at the end demand point. And just like all these others, the gaseous energy value chain looks very similar, with gas production, be it natural gas production or renewable gas production, feeding transmission pipelines and distribution pipelines, with either pipeline storage through line pack or underground gas storage, and then the thermal use or chemical use or internal combustion use of gas at the end of the day. Now, this energy medium or energy pathway way of viewing gaseous energy becomes a little bit more clear when you look at transmission infrastructure across Australia. On the left-hand side, we have electricity transmission, moving wholesale quantities of energy from large supply to large demand. And on the right-hand side, we have gas pipeline infrastructure, moving gaseous energy from large supplies to large demands. Interestingly, you'll notice that there are actually less pipelines than there are gas pipelines than there are electricity transmission power lines, despite the fact that we saw before that there's more gaseous energy used than electricity. That's part of why we see in today's terms that energy in the form of gas is cheaper than electricity. The yellow lines being electricity, the blue lines being gas. Despite the price increases that we have seen in gas over the years, current gas prices, be it wholesale or retail, are lower than electricity prices. And we expect this to continue. Future gaseous energy infrastructure, even for hydrogen infrastructure, is still expected to cost less than electricity infrastructure for the same volumes of energy being transported. Now, this data is specifically from the European Hydrogen Backbone Initiative. Encourage anyone to go have a look at that. But importantly, though, that is relative to Europe. APGA is in the process of undertaking its own research to consider this relationship in an Australian context, considering Australian conditions. And from historical experience, we expect a very similar outcome, and we'll make that available for everyone once we finish off the research. Understanding that gaseous energy is already cheaper and the infrastructure is going to stay cheaper, it's not really super surprising that when we analyse the net cost of gas decarbonisation, we find that decarbonising gas demand is cheaper through green hydrogen than it is through electrification. And this is a really important point. We can electrify gas use, sorry, we can decarbonise gas use through electrification, but we're finding through analysis that it's cheaper to do it even through green hydrogen. And that's a really important point when you consider just how much gaseous energy we use, especially in a place like Victoria, where we use, I think Victoria uses 27% of end-use energy being from gaseous sources relative to 17% electrical. And you'll notice there that the big swings between winter and summer energy demand are all predominantly absorbed by gaseous energy as well. To try to decarbonize this large energy demand, it makes sense to try and focus on the lowest cost option to achieve that decarbonisation, considering there is so much energy demand in this particular form. And what it ultimately all comes down to is this: the retail cost of energy breakdown between electricity and gas. And by this, I actually mean this, because we have a problem in Australia where we often talk about energy costs in different units. On the right-hand side, 7 cents per megajoule in gas cost equates to around about 25 cents per kilowatt hour in electricity costs. That's on a like-for-like comparison. We'll notice here when we look at the wholesale cost of energy in retail energy costs around Australia, the wholesale cost of gas is currently less than half of pretty much everywhere. Now, considering that we're expecting the wholesale cost of renewable gases to be possibly double the wholesale cost of natural gas, that sounds scary in itself. But when you compare it to the cost of wholesale electricity in a retail energy breakdown sense, you're still only really just coming up to the current cost of retail electricity, and wholesale electricity is expected to increase as well. The Grattan Institute expects wholesale electricity to reach $100 per megawatt hour in a net zero emissions NEM, not let alone a fully renewable NEM. So on a wholesale energy cost basis, looking at how that impacts the household and business energy prices, you're actually not taking that much of a step up by doubling your wholesale gas cost. Now, if we can achieve this through renewable methane alone, we don't even really have to modify the infrastructure. So the remainder of the gas chart can stay the same. If we needed to do it through hydrogen infrastructure, there is going to be an increased cost. But with hydrogen gas pipelines being cheaper than electricity power lines, the relative increase in network costs are expected to be less than if we were to achieve try to achieve the same decarbonisation through electrical infrastructure. And that kind of changes the question. The question is no longer, what if renewable electricity didn't have to solve the entire problem alone? But the question is, what if renewable electricity didn't have to solve the entire problem alone, and that made decarbonisation cost less? And that really is why I'm so passionate about renewable gases, because that's what we're talking about. We're talking about an opportunity to achieve the decarbonisation that we're looking for as a nation, but to do it in a way that utilises more than just one set of technologies, utilising 2 sets of technologies side by side in unison to solve the problem in the least cost way possible. And I think that's really important for Australia and how we move the entire nation forward on a decarbonisation pathway. That's about all I had. Thank you very much for listening to me rabbit on about my passions in renewable gases, and I'll hand over to Kristen, or back to Lucy, one of the two.
Thanks, Jordan. Yeah, no, we can hand over to Chris. So now I just want to say thanks for your presentation, and especially interesting to hear that cost argument around, renewable gases potentially being a cheaper option than electrification. I'm sure we'll have some questions for you later, and yeah, just encourage everyone to put your questions in the Q&A section on Zoom, and we'll address them after Kristen.
Looking forward to it.
Okay.
Perfect. Thanks, Lucy, and thanks, Jordan. The problem going second after you, Jordan, is that even though we spoke about our presentations beforehand, I feel you have stolen not only some of my thunder, but also some of the images and the charts that I was going to use. But and also, you're very passionate and a very good speaker about it. So, so I feel like maybe next time I'm going to try and ask to go first, so that then we can finish really strong. But it is what it is, and I'll do my best. And even though some of our graphics are similar, I think some of the messages are consistent, which is obviously a good thing, but a slightly different perspective, and actually how industry is responding to these aspects. So before I get into that, a little bit about us. So I am Head of Strategy and Innovation for Australian Gas Infrastructure Group. We are one of the largest gas infrastructure businesses in Australia. We own assets across that value chain that Jordan showed you, and also across the country. So that extends from the likes of the the Tabrigi Gas Storage Facility, which is a 60 petajoule gas storage facility in Western Australia, to large-scale transmission such as the Dampier to Bunbury natural gas pipeline, to being the largest gas distribution business in Australia, servicing more than 2 million customers across South Australia, 2/3 of Victoria, half of Queensland, and several other regional centres in the likes of New South Wales. We are also now proudly a renewable gas producer out of our Hydrogen Park South Australia facility, but I'll get to a bit more on that later. Our vision is to be the leading gas infrastructure business in Australia, and to us that means delivering for customers, being a good employer, and being sustainably cost efficient. And I mentioned before that we have assets across the country and serve millions of customers. But what we actually do is we deliver them energy, and we do that safely and reliably, and we do it at lowest cost, and we continually check in with them to make sure that the services that we're delivering them are in line with their expectations and with their needs. And what we hear from our customers is that they like gas, especially for cooking, for hot water. Many industry rely on it. They also like the reliability. I mean, on average, I think our distribution customers have an unplanned outage once every 40 years or something, which is quite good when you might compare that to the likes of electricity. And I have to say, that's not because electricity aren't doing a good job. Obviously, our assets are just underground. It's the nature of it. We are not as susceptible to storms and aspects like that. Also, our customers understand the need to decarbonise. They understand that it needs to happen, that it should happen. They understand it might cost a bit more, but they don't want it to cost any more than it has to cost. They want it delivered at the lowest possible price. And so that's what we hear from our customers. The other interesting aspect of that is customers just know they get gas. A lot of time, I mean, everyone on this call will know that gas is methane, but on average, the customer doesn't realise what sort of gas they're getting. It's just gas to them. And I heard an interesting story actually from one of our sister companies in the UK. He went up to one of their customers and said, do you have gas in your home? They said, yes. He said, do you know what sort of gas it is? They said, yes, it's natural gas. And he said, yeah, but do you know what sort of gas? No. Do you know it's hydrogen? No, I didn't know that. That's good. It's not hydrogen, of course, it's methane, but the basis of that is just people don't really know. They just expect to get a gaseous energy, the flame, safely and reliably, and that's what we deliver them. But as I said, customers want and expect us to do more, and Jordan showed this graph that I've also got on my slide deck there. And similar to what Jordan said, all I'm trying to highlight here is what we've actually got to decarbonise is that black line. And that's a big line. And in Victoria's sense, it has a lot of peaks and a lot of troughs, and they're not as evident in other states. But still, that decarbonisation line is a big challenge. That is transport, that is direct use gas, and that is electricity. And as a country, we've made really good progress on electricity, but we need to do more in transport and direct use gas. And it's not, the modelling indicates that trying to do that using the infrastructure that we've already got, being the gas pipelines and the electricity infrastructure, will deliver that at lowest cost. Trying to put all that load and that peakiness on the existing electricity network could result in, would result in significant investment being needed, particularly around electricity storage. And we know that gas is a great energy carrier and storer. So it makes sense to use our distribution networks and our assets to deliver a renewable product. And in saying that, our distribution networks, we've been undergoing a mains replacement program. We are nearing the end of that from an AGIG perspective, and those polyethylene networks are capable of carrying 100% hydrogen. So we can use the assets that are already in the ground to deliver them with reliable gaseous energy still, and that will help them to achieve lowest cost decarbonisation. Now, it's at this point that I usually get in trouble, because one group of people will tell me, Chrissy, you need to be firmer on renewable, gas is the way forward. But our perspective is, it is not about gas versus electricity. Renewable electricity is great, batteries are great, but it can't do it all. And in fact, using renewable gas can help use the renewable electricity more efficiently. So we're entering into times now where you've got solar being curtailed in the middle of the day, you've got wind farms being curtailed in the middle of the night. Electrolyzers and producing that renewable hydrogen can actually use that more efficiently for customers, and it can also encourage more investment in these sources, so perhaps where electricity networks are constrained. So for us, it's not about one or the other. It's about using everything that we've got, the pipes that exist in the ground, the renewable electricity that we've got, to the most efficient way possible. Again, this is another slide that Jordan's already covered, and I've taken a more simplistic approach just to define what renewable gas is. So I won't spend too long on this, other than to say it is really important in an engagement sense. I mean, we've done these projects and we've been engaging with customers on this a lot. And there is a perception of, I hope you're not sort of greenwashing. And so it's really important to illustrate that what we're talking about here is not about offsets and planting trees, but still using carbon. This is real sort of green and renewable molecules, or carbon neutral molecules, that will flow through the existing network. So what are we doing as industry, and what are we doing as a business specifically at AGIG? So I'll start a few years ago in 2017, when all of industry came together, which was really a really important step to show unity, where we said, there is a pathway for renewable gas. You understand renewable electricity, understand there is a pathway forward with renewable gas, and we're going to get on with delivering it. We're not going to wait for government policy. You know, in the next 5 years, we're going to start biogas and hydrogen demonstration projects, and then we're going to start to deliver meaningful decarbonisation and network conversion. So that was in 2017, and obviously work from industry started a while before that. And whilst these timelines are quite broad, they were really important to starting the conversation. And I'm really proud that following on from that, Australian Gas Infrastructure Group has come out with our own low carbon vision and strategy. And what we're committing to is 10% renewable gas across all of our networks by 2030. And 100% conversion by 2040 as our stretch target, but certainly by no later than 2050. So most states and territories now have decarbonisation targets of 2050 or a couple by 2045, and we certainly want to achieve renewable gas before that. So this is our targets. 100% by 2040, and that's renewable hydrogen and biomethane. And from my perspective, my view is that it will be probably a combination of both. Some areas might be better suited to biomethane and others to renewable hydrogen. These are pretty challenging targets, I'm not going to lie. It keeps us busy here at AGIG, but it's really important to set these targets. There's a lot of work to do. We showed how long it's taken us to get to where we are with renewable electricity, and that's only a part of the overall energy picture. So we've got a lot to do, but we're really committed to it. And the good news is we're already making good projects. So this is just a map of our projects, but I'd also like to point out that we're not alone here. And I saw the guest list before we came on, and I know that there are a lot of you on the call whose organisations are also doing renewable gas projects, be it biomethane or renewable methane, or indeed other hydrogen projects such as the Western Sydney Green Gas projects. But obviously I'm just going to focus on what I know most about, which is our projects. So we like to sort of turn the country that shade of green. We've got various projects across the country, and I'll talk more about our production projects in the second, but obviously Hydrogen Park South Australia is our flagship project that is online and producing renewable hydrogen today. We've got Hydrogen Park Gladstone, which is under development, and then 2 10-megawatt projects which have received funding from ARENA, and we're working towards final investment decision on them now. A few things that I won't get into in a lot of detail today, but I'll just mention we are doing, or have just recently completed, a feasibility study into blending hydrogen into a large transmission pipeline, the Dampier to Bunbury pipeline in Western Australia. And also we have established the Australian Hydrogen Centre. And we did this with the support of ARENA and the state governments in South Australia and Victoria, and also with support from industry partners like AusNet, Neoen and Ongi. And what that virtual centre is doing is feasibility studies into 10% and 100% blending across South Australia and Victoria. So you can see, I'll speak to in a minute, the fact that we're doing these demonstration projects and we're delivering projects for large-scale blending, but at the same time and in parallel, we're doing the feasibility into indeed how we could, oh my goodness, the lights in my office have just turned off. There we go. I must have not moved enough. But we're delivering these feasibility studies into how we would do 100% across the networks. So what are the actual projects? And I'm really pleased, actually, the photo of Hydrogen Park South Australia there, that's a real photo. It looks a bit like an artist impression, but you know, I come from a gas industry. Most of our assets are underground. So we went for a time when we did not have many photos of our assets. And now we've got a few really nice ones of above ground assets that we're able to show on slides like this. So that is the real life Hydrogen Park South Australia. It's a 1.25 megawatt electrolyser, relatively small, but the largest in Australia. And that was launched in May this year. And that's producing renewable hydrogen, and it's blending it to more than 700 homes in the nearby suburb of Mitchell Park. And that's really important, and that's an Australian first project delivering to a sectionalised part of our network. And this is important because for us, hydrogen is not necessarily a technical challenge. We used to run on Towns gas, which was 50 to 60% hydrogen. We know appliances can run on 100% hydrogen. We roll out the hydrogen barbecue every chance we get. So it's not a technical challenge to build these things, and indeed electrolysis has been around for many years. But we're using it in a different sense, and this is in suburban Adelaide, this facility. So what was important was the socialisation and the normalisation of hydrogen and blended renewable gas in that standpoint. And the really great thing about that community is it wasn't, you know, there weren't questions of why are you doing this, why here? It was more like, of course you should be doing this. Why haven't you been doing it sooner? And when can my friend in the next suburb over get it? So it's really great to see that this is in line with what Australians are expecting of us. That facility also supplies industry. So we have an agreement with BOC. You can see the BOC truck in that photo. They, instead of supplying industry in South Australia with hydrogen produced from conventional steam methane reforming, which has carbon associated with it in Victoria, they will now supply that industry with renewable hydrogen from this facility. And that's another great thing about using hydrogen domestically, is that the market is already there for it. So often when people talk about why hasn't this taken off earlier, it's a bit of a chicken and an egg thing. You know, if you talk about in a refueling sense, someone will bring you the cars if you promise to build production and refuelers, and someone else will build production if you promise to bring the cars. It's really hard to get it all to line up and to underpin significant investment of relatively small markets. But the gas network is a large market, and it is there today, and it can take blends of hydrogen without changes to downstream appliances, you know, up to say 10%. So we were able to fund this facility off the back of that distribution blending, which will deliver not only decarbonised product for our customers, but it also means that now people like BOC have the opportunity to contract with us and to bring together more of an integrated system. So it's a really great example of that. We're already on to the next one, which is Hydrogen Park Gladstone, that received funding from the Queensland Government. That will be the next step in our journey. It will do up to a 10% blend. So Hypersay was 5%. We're now doing a 10% blend to the entire network of Gladstone that has residential and business customers in it. So again, you can see the next step up there, which brings me to our next projects, which are the 10 megawatt projects that were recently funded by ARENA in May. And these would do, you know, again, up to 10%. And you can see there, Hype Murray Valley, that's going to deliver up to a 10% renewable hydrogen blend to more than 40,000. Well, actually, I didn't write that on the slide, but it's more than 40,000 customers in Albury Wodonga. So again, you can see the step up there. It was 5% to over 700 residential customers at Hypersay. We've then done up to 10% to residential and business customers in Gladstone, and then Murray Valley will deliver up to 10% to 40,000 connections in those regional towns. So it's pretty exciting, and you can see there that we're on our way to that 10% across our networks, and that these will deliver those learnings. So getting back to customers, because at the end of the day, that's the most important aspect of what we're delivering. And what it means for us is that we can work with customers to deliver them renewable gas solutions, and they want them. They want to know that they can decarbonise their gas, as I mentioned before. So these molecules are in the networks today. Customers can essentially do nothing and we'll do the hard work. As I said, we're targeting 10% across our networks by 2030 and 100% by 2040. We know that renewable gas certification is happening as we speak, in that, you know, the federal government is working towards that. Gemini are doing some good work. We're talking to people about how we can use Hypersay as a demonstration and a testbed facility for these schemes. So just as you could buy certified renewable electricity today, in the future you'll be able to do that, which means you could essentially decarbonise all of your gas supply quicker than even our targets of 100% by 2040. And then, of course, there's the innovative solutions. So working with customers to deliver an innovative 100% solution just for them. And one thing I didn't mention was that on our low carbon strategy, we are actually targeting having a 100% renewable gas network by 2025, which is quite seen the way the years are flying by at the moment. And ultimately, what we want to deliver and what we think is important for keeping prices low, for keeping energy delivery reliable, is an integrated energy solution. So better use and more renewable electricity, because there's a new market for it, and that market is electrolyzers, which can ramp up and ramp down. We can also integrate with wastewater treatment facilities, and that's indeed what we're doing at Hype Murray Valley, which is co-located with wastewater treatment plants. So we'll look to sell them oxygen, use their water, and they're considering biomethane production. So again, you can see the sectors coming together, and ultimately what that will deliver is lowest cost decarbonisation for customers, and as well, hopefully some jobs and growth. So at Hypersay, you were able to see that whilst our main priority was decarbonising domestic energy use in homes, we were also able to decarbonise industry through that contract with BOC. So there are other use cases for this hydrogen, which using the domestic homes and business sector really helps to underpin. So that's about it. I mean, the main message is here is that gas is changing for good. And customers at the moment, they don't really need to do anything. We're doing some of the heavy lifting, and it's really important that we do that to drive down costs. So the 10% blend will help to drive down those costs of hydrogen and even biomethane, to demonstrate them, to socialise them. And ultimately, we're targeting a cost parity with natural gas, so sort of H2 under 2 by 2030. And then we can start to sectionalise and decarbonise all of our networks as we target 100% renewable gas by 2040. And importantly, that's aligned with what our customers are telling us they want. They like gas, they like the reliability, they like the flame, they know they need to decarbonise, and they want that it delivered at the lowest cost. This is not the future. The future is here now. These molecules are being produced as we speak, probably down at Hype SA, and it's only going to increase. There are many more projects. I'm going to do a gas joke and just imagine that at the other end of the computer screen, everyone's laughing. There's many more of these projects in the pipeline, and we've got a clear vision for the future of how we're going to deliver it. And the nice thing about this industry is that we're all working together at the moment. So I speak to Gemina, we're working with ATCO on a project. People understand the need to drive this industry, and we're all working together to do it. So it's a pretty nice time to be involved, actually, and a pretty exciting time as well as we turn ourselves into a decarbonised gas industry. So that's about it from me. And I'm a bit concerned, Lucy, that there are 42 questions in the Q&A. I'm going to assume that they're all directed towards Jordan.
Thanks, Kristen. That was a really insightful presentation. Really exciting to hear about some of the projects that are already in operation, and many to come in the years, or in the next 5 to 10 years. So it's really already on us, the renewable gas time. So yeah, thanks. We've had lots of questions already in the Q&A function. We just encourage everyone to keep posting those questions in the Q&A box. So we'll try and pull out some of the key questions. One of the themes I've noticed popping up is around the blending percentage in for hydrogen and gas pipelines. So maybe a question for you, Chrissy, to start off with is, what is that maximum percentage that you can blend in a gas pipeline with hydrogen? And then what are the implications for users' appliances if you go above that?
Yeah, look, that's a good question, and it is one that gets a bit confused, because I remember in the National Hydrogen Strategy, they didn't make a recommendation about blending in pipelines, and the reality of that is because there's two sorts of pipelines there's many sorts of pipelines, but in the context of this discussion, we're talking about the large-scale transmission, high-pressure pipelines like our Dampier to Bunbury natural gas pipeline, like Yamemba to Sydney or Yamemba to Adelaide, or there's distribution pipelines or networks. So if we start with the larger scale ones, they're really bespoke. So the amount of hydrogen you can blend in those pipelines will depend on many factors. It might depend on the type of steel that was used, the operating pressure, how close it is to MAOP, and how much those pipelines cycle throughout the day, so how much their pressures are changing. So each of those pipelines will really require an independent assessment to understand how much they can blend. And often it's not necessarily like you cannot blend it, it's at that pressure, the amount you can blend may be less or more. So it's really quite bespoke for those sorts of pipelines. For our distribution networks, the majority of them are either already polyethylene next generation plastic pipes, and we've done that for safety reasons. So we've been going through mains replacement for 10, 15 years. Some of our programs, like R1 in Victoria at Australian Gas Networks, is coming to a conclusion in the next 5 years to replace all our older cast iron and steel, unprotected steel mains with these next generation polyethylene. And the research is indicating that those pipelines could essentially take 100% hydrogen today. The limiting factor for us is more so on the end user appliances, and that's not because appliances can't run on 100% hydrogen. It's because the appliances that are in our system today are designed to run really efficiently and really effectively with natural gas. Now we've got 100% hydrogen barbecue. We're bringing over some 100% hydrogen stoves and gas heaters from the UK later this year that I'll have on display in SA and Victoria. So 100% hydrogen appliances exist. It's just that we don't manufacture our appliances at the moment to run on them. So the research that we've done indicates that probably 10% is where you would get to with our existing appliances in Australia before you look to go to 100%. And again, this it's not easy, but nothing about this transition is easy. But either way, even if you electrify everything, you've got to change your appliances, right? And that's actually a really harder change than what could be a change to a hydrogen appliance, because you would have to decommission all your gas infrastructure. It's not like for like. And what we're seeing in the UK is what they're actually doing is looking at hydrogen-ready appliances. So you could buy new appliances today that run on natural gas, but they're hydrogen-ready. So when the time comes to transition to 100%, a gas fitter comes in, changes over the burner in less than an hour, and you're ready to go. So it's a really minimal impact. So that's probably how we expect the transition to occur with appliances. And a very long-winded answer to your question. Sorry.
Good. And maybe a follow-up question relating to that is what role will the industry play in supporting that consumer transition that would be required? So any, change in appliances, how would that work? How would industry work with consumers in that?
Look, good question again. And I think the general answer there is we'll do whatever we're best placed to do. So either way, there will have to be a uniform transition. At the moment, what we're focused on is driving down the costs of hydrogen, which will help with that transition. We're also working with the appliance manufacturers to understand what the best way to get those hydrogen-ready appliances in circulation is. So is that a policy change that now says your appliances must be ready for this transition, or what does that look like? So that's where we're focusing our energy at the moment. I suspect that when we have the large-scale rollout, just like when we switched over from Towns gas to natural gas, there was a similar rollout. We'll take learnings from that, and there are some people around who even worked in that rollout. So we'll probably be calling on them and saying how was the best way to do it. But if it's a question of costs and support or even technical support, we'll do whatever governments and all of industry comes together to say is the most efficient way to do it. But we are conscious of costs and making sure that this transition is delivered at the lowest cost possible. Okay.
All right, Jordan, a question directed to you is around safety considerations. So are there significant safety considerations for gases and gas infrastructure when compared to electrical infrastructure that will influence the overall cost of implementation of renewable gases? So specifically thinking of hydrogen distribution in this case.
Yeah, and I guess a good way to start with that thought is that we have both a really strong gas and electricity industry today, both with their own inherent risks, and both which are industries that make their bread and butter off of doing what they do really safely. On an international perspective, Australia's gas industry is seen as one of the safest in the world. We've got some of the lowest rates of loss of containment and that type of thing. So when we transition from our existing industry to an industry that considers another flammable gas, it's mostly going to be about considering what's different with these gases. So from an actual, once you've actually got the assets in the ground and everything's turning and burning, as we say in the gas industry, essentially we will be applying the same types of risk assessment and risk management methodologies, but taking into account the slightly different physical physical properties of the new gas. So, you know, it's a little bit lighter in certain ways, it behaves in slightly different ways, but these are all well within the range of the expert you know, gas infrastructure operators we already employ to keep us safe in our you know, in our industry. There's definitely a focus on upskilling through the transition, and there's a lot of focus through the Future Fuel CRC, through the National Hydrogen Strategy. There's been a big investment suggested up in Queensland around that type of jobs focus. But it's essentially going to build on the long, strong track record our existing gas industry has of delivering energy in a safe manner. Sorry. On top of that, there's the actual asset infrastructure side of things, where, as Chrissy said, there are you know, there are different materials properties and things like that, where our existing assets will have a case-by-case upper limit of hydrogen that can safely be transported in them. Those types of composition constraints are something that the Australian gas industry works with day in, day out already, with the compositions that we already manage. So there's a strong track record there as well. But then, you know, it is very completely possible and practical to build 100% hydrogen pipelines brand new today. And then that comes back to that other conversation about, well, if we're decarbonising either through electrification or hydrogen, we've got to build the generation, the electricity transmission, and replace the appliance anyway. Building lower cost transmission, a lower cost appliance change is going to result in we're expecting to result in a lower cost decarbonisation option. So yeah, you've got the option to go brand new 100% hydrogen safely already.
It's probably a good segue into my next question that's come from the audience, is around replacing electricity in large electricity interconnectors with green hydrogen generation plants, and piping it through gas pipelines rather than building you know, the large electrical infrastructure required. So the question was, so they've said this might have been a component of your cost comparison from earlier, but they'd be interested in a direct cost comparison of gasification to the cost of electricity transmission.
So yeah, that I saw that question. I really like it. It's thinking like a pipeliner, which is a terrible thing for me to say, but no, it's a really good thought. You know, we've got energy production, we've got energy demand. How we get it from A to B is a big piece of that puzzle. As far as create hydrogen, transport hydrogen, recreate electricity, I haven't seen the economics for that. What we have been looking at is the economics of hydrogen end use. So if we're comparing, you know, say an area like Sydney, which you have the option of either electrifying that entire gas grid or converting that entire gas grid to hydrogen. That second option, you've also got two options inside that, where you say, well, do we then electrolyze the hydrogen close to the demand, or do we electrolyze the hydrogen close to the renewable electricity source? And when we start looking at that conversation, we've got a renewable energy zone proposed up in the New England area, about 1,000 kilometres away from Sydney. What the European analysis suggests, and what we're hoping our analysis is going to also show, is that we expect that electrolyzing closer to the electricity generation is going to be and then piping that gas to Sydney would be a lower cost option than building all of the electricity transmission to get that electricity to Sydney and then electrolyze at that location. And that also answers another question I saw that I quite liked, and sorry to jump in there as well. The idea that you know, using renewable electricity to then turn that electricity into hydrogen, it could either increase the cost of the system, or that might be kind of economically result in a higher energy cost situation. To that, I'd add to the point that if we're able to produce bulk hydrogen close to a renewable electricity source, that renewable electricity doesn't have to come into the NEM. That means we're able to access behind the meter utility scale solar to produce the lowest possible cost hydrogen through electrolysis directly at that electricity generation source. You don't have to worry about all the transmission lines. You don't have to worry about the storage issues. You don't have to worry about the synchronizers, the keeping the AC signal in spec. You don't have to worry about any of that. You can just put the electricity straight into the electrolyzer, gas straight into the pipe, transport it to your use source, and you've got a much lower cost value chain for that energy. So hopefully those two pieces of the picture tie into the explanation. I don't know though, I'm looking at that full value chain of replacing an interconnector. Would love to do the math, but I wonder if the whole gas electricity pathway it might be too many bites at the efficiency cherry.
And look, I'd just like to add to that. I think that's a really great summary, Jordan. And indeed, when we're looking at a Australian Hydrogen Centre feasibility studies for South Australia and Victoria and the 100% conversion, a key part of that is, where do you put the electrolysis? And so those reports will be released next year. But I think it's a really interesting question, because you can answer all of these things theoretically and say all of the electrolysis should be put here, and then we'll build all these pipelines, or we'll build all these electricity networks, and this is how it will roll out. In reality, that's one scenario, but the whole likelihood is that it will be a combination of everything, and it should be, because you've got transmission networks already there and they should be utilised to the maximum extent possible. We've got gas pipelines already there. They should be utilised to the maximum extent possible to deliver the most efficient energy system. We should make use of what we've got and then also build new things where it makes sense to do so, and we should build things that make sense for that solution. So it might be that there is a great renewable electricity asset located somewhere, and we'll deliver the best solution that brings that energy to market, be it in the form of hydrogen, or be it in the form of electricity, or be it in the form of hydrogen that's then used as electricity. It'll depend on each specific development. And that's not to say, we should definitely do the feasibility studies to say what is this theoretical solution, but what we all know is that the market will evolve, and it will evolve in a way that meets customers' needs, and so it should. It's just about making sure that we don't have policymakers saying everything needs to be electrified because that's the pathway that they can see, or everything needs to be hydrogen. Not that they're doing that, but it's about saying there are many pathways, and we've got great natural resources, and we've got existing infrastructure that can deliver this for our customers, and we should make use of it in the most efficient way possible.
Couldn't agree more. Exactly.
All right, we've only got a few minutes left, so we'll just round up with one final question, which I think is a good one to finish on. So question for both of you. So this audience member has said, we're in the midst of a climate emergency. Given our current trajectory, by 2030, global warming will already be 1.5 degrees. What are the constraints to delivering 100% green hydrogen and or biomethane earlier than 2040 as per your targets? Kristen, do you want to start?
Yeah. Look at us all jump in. What are the constraints? Well, I mean, one of the things that I didn't mention in my last slide is, what are the enablers for this market? And what we're doing at the moment has been really supported by funding. At the moment, it is more expensive to deliver a hydrogen because it's not, when we build HyperSA, that electrolyzer was hand built in Germany in Siemens shed. It wasn't in a big manufacturing gigawatt factory size sort of scale. So what we need is scale and certainty for investors to invest. And so, that's why I know our friends at Gemini have been asking for sort of some policy in that respect to sort of give certainty to appliance manufacturers, to electrolyzer manufacturers, to invest in those sort of factories that will drive down the capital costs of these assets. So I think policy like that can help. We are already, however, seeing cost reductions. Let's not joke about that. We've just gone out for tender for our hydrogen park Murray Valley, and I can tell you today, if I was building HyperSA, I'd be able to build it a lot cheaper than I was able to 2 years ago. So I think, what are the constraints? We should think a bit more about what are the enablers to bring it faster, and that would be some sort of clear direction and incentives to build more of these to drive down the costs and yeah, to help industry to make those commitments. And that's indeed what's got renewable electricity to where it is today. Those costs, the cost curves that you saw with batteries and solar and coming down to where they are now, that was enabled by that certainty. And the same sort of messaging in the gas space will help us along that transition, and that will be really the main driver, I think, to get us there. Jordan, I'm not sure, you might have something else to add.
Not too much more. Recognising that the renewable gas industry is in ways around, it is less developed than the renewable electricity industry, but it is developing at a more rapid pace. So it's a really interesting context when you look at the history of renewable electricity development and how that scaled up, and compare the scale of an industry that and of the biogas industry alongside that as well. I think you really covered it off really well there, Chrissy. I think the only other thing that I'd say, I'd take it to the other end of the conversation from how we get there to or how we get from where we are to get there. Depending on all of the options to get to 100% gas decarbonisation before 2030 would require a lot of dedicated, asset development that's not in line with the way that the Australian economy works. The Australian economy is based on a commercial model. People build assets because there's a business there, and things get built. To either go the electricity path or go the gas path before 2030, 100%, we would have to bypass that and force the development of things. And that causes two problems. One problem is it makes us force all of our assumptions right now and build on those assumptions, and we don't get the opportunity to learn from those assumptions. We also don't get the opportunity to benefit from the improvements in technology across the next 10 years. And I think that's the really exciting thing about the next 10 years in renewable gas, is we're really just at the start of this journey, just like the renewable electricity industry was, say, 20 years ago. And we're right on that doorstep, and we see those of us who have been involved in we see this potential just in front of it. We just need that 5-10 years to learn everything we need to know about it. And by the time we hit 2030, I'm very confident we're going to have 10% hydrogen networks. I think we'll have more than 10% renewable gas in our networks, and we'll have so much more knowledge that we'll be able to apply, just like the electricity industry did over the last 10 years, over the next 10 years, to hit the same heights the renewable electricity industry has hit in recent times. So.
Yeah. Really good point. I think, if you try and accelerate it beyond that, the risk is obviously increased costs of delivering it. That 10% by 2030 should deliver us reductions in the cost of producing these renewable gases, which then mean you can do the 100% conversion with as minimal bill impact as you can, and all in the context of this is still the lowest cost pathway to achieving it. So it's a really tricky one to accelerate it, but I think we're all committed to doing it as fast as we can with as minimal impact as we can.
Yeah, thanks. So it really sounds like there's a balance there of not, jumping into it too quickly, but going about things the right way and to achieve those targets that are being set.
Still with the pressure on. Yeah.
Yeah, that's right. It's good to hear your optimism as well, Jordan. Yeah. Great. Well, we're over time. Unfortunately, we had plenty of questions, so sorry we weren't able to address them all, but we'll definitely have a look through them after the event and appreciate the engagement from the audience online. I'd like to say thank you to Jordan and Chrissy for presenting tonight. We really appreciate you taking the time out to educate us on renewable gases. I'm sure we'll have plenty more topics in the future relating to this. There's plenty happening in the space, and thank you very much. Thanks to our audience, and we look forward to seeing you at our next event.
Thank you. Thanks for the opportunity.
Thanks all. Catch you later.